For our physics project, me, Peyton, and Sarah decided to try to find the coefficient of friction between wood and three separate surfaces. To do this, we first weighed each object, then we ran our trials, then we did our calculations.
For our first trial, we started with a wooden block that weighed 24.87 grams, and I'm going to tilt it and stop when the wooden block starts to slide. Now I'm going to use the measure app to measure the angle.
22 degrees.
Now we're going to redo the process with the pencil sharpener that weighs 20.77 grams. So I'm going to tilt it until it starts sliding. Now I'm going to repeat the process and measure the angle.
17 degrees.
Now I'm going to do the same thing for the AirPods case that weighs 46.55 grams. And I'm going to stop when it starts sliding. Again, I'm going to repeat the process and measure the angle.
23 degrees.
Now that we have all of our data, we're going to move on to calculations.
The forces of an inclined plane are the mass times the gravity, which goes straight down. Secondly, we have the normal force, which goes perpendicular to the surface of the inclined plane. The angle between these two other angles is the angle of the incline, which we will be focusing on. The force making the object move will be called the force in x direction, which makes a 90-degree angle with the normal force. To begin, we'll solve for friction loss using the formula friction loss is equal to normal force times the coefficient of static friction, which we can rewrite as friction loss over normal force is equal to the coefficient of static friction. In our experiment, we'll be taking the minimum angle just before the object begins to slide, which is the angle where the force in x direction perfectly cancels out the friction loss, leaving 0. By rewriting this equation, we know that the force in x direction is equal to the friction loss. We can now plug in the force in x where the friction loss was in the previous equation. Because our angles form a right triangle, we can now use trigonometry to solve for the normal force leg and the force in x direction leg. So the mass times gravity times the sine of the angle will get us the force in x direction. The mass times gravity times the cosine of the angle will get us the value for the normal force leg of the triangle. Because it's in both the numerator and the denominator, the mass times the gravity gets cancelled out, so we are left with the sine of the angle over the cosine of the angle equals the tangent of the angle, which is equal to the coefficient of static friction. We will use this much simpler formula to solve for the coefficient of static friction for our trial. Using this formula, we took the tangent of each angle and found that the coefficient of static friction between wood and wood was 0.404, between plastic and wood was 0.307, and between polycarbonate and wood was 0.425.